In this lesson, we'll determine an x value for a given value of y in a function. In my example, f of x equals x squared plus 2x minus 3, I want to determine the x value needed when f of x is equal to 5. To do this, I can take the 5 and replace f of x with 5. In other words, my y value is equal to 5. What x value would give me that y value? Let's solve this equation. I can subtract 5 from both sides, getting all the terms on the same side. It's quadratic, so I can solve by factoring our quadratic formula. In this case, I'll factor it, setting each factor equal to 0, and solving. I get values of -4 or +2. In other words, I would have two values of x that give me a y value of 5 for this function. These points would be on the function 2, 5, and -4, 5. Let's look at the graph of this function. Notice that we have the point 2, 5, and -4, 5. In other words, here's where I have the value of 5 for y, and it intersects the curve in two places at -4 and a +2. Let's look at another example. Using the same function, let's determine x when f of x equals -3. Pause the video, find the values of x that give us a -3 for a y value, and then come back to the video to check your answer. If we replace f of x with -3 and solve, I can add 3 to both sides. I can solve this by factoring. Set each factor equal to 0. I get x values of 0 and -2, or in other words, points of 0, -3, and -2, -3. If I look at a graph of this function, I want to determine the x values when y is -3. Y is -3 down here, intersecting the graph at -2 and at 0. Let's use the same function. And determine the x values that would give us f of x equal to 0. So pause the video, solve for x, and come back to the video to check your answer. In this case, we replace f of x with 0 and solve. I'll solve by factoring again. Setting each factor equal to 0. I have x values of -3 and 1, which means I have points of -3, 0, and 1, 0 on the curve. Because the y value is 0, these points are on the x-axis, which tells us that we have x-intercepts at -3 and at 1. If I look at a graph of this function, we can see that we have x-intercepts at -3 and +1. Now in each one of my examples, the values were really nice. We could solve each one of the equations using factoring, but this won't always happen. There are times where we may have to use the quadratic formula to give us the exact values or decimal approximations of the x-intercepts or points on the curve. Also, you may have a polynomial of higher degree than 2, like a x cubed or x to the fourth, that may cross the x-axis in several places, and those places will be decimal values. You may have to use the capabilities of the calculator to calculate where those points are.